All right, so let's try example number 7. In this example, we're asked to do two parts. We're going to find the derivative of the function at x equals -5, and then we're going to use that information to find the equation of the tangent line of the function at -5. So let's just begin from the first one, and then we'll go over the second part. All right, so the first one is asking us to find f prime of -5, given that the function is 4x squared minus 6x plus 4. Now we gotta be careful here, please. So it's a very important problem because I want to go over how to interpret this part. So what this is saying is, first you're gonna take the derivative of the function, and then once you find the derivative, then you're gonna evaluate it at x equals -5. So first find the derivative, and then you input x equals -5. So what I'm saying here is first let's do the derivative. So derivative of x. So we have 4 times the derivative of x squared. So we bring down the power 2 times x, and then subtract 1 from the power. That gives us 1. We usually don't write that power, but and then minus 6 times the derivative of x. So there's like imaginary 1 there, right? But pretty much we know that derivative of x is 1, followed by the derivative of a constant, which we know is 0. Now, so we found the derivative to be f prime of x equals 8x minus 6. Now, I want to make sure that I point out here that that we have to be careful on our notation. We need to make sure that once you compromise of taking the derivative of that, right, then the whole thing needs to be the derivative, right? So this has to equal the derivative of this. Now, also something that I see here a lot of times, very not good, is I see students doing this, right? They will just go like this, 4x squared minus 6x. This is not correct. And then we'll just do the derivative of this is 8x minus 6. That's not correct. You're saying that the function equals the derivative, right? That's not right. So you have to actually make another line of it, and to tell the reader that that's a different function, and that function is the derivative. All right, so the second part of this now that we found the derivative is to evaluate at x equals -5. So we have f prime of -5. So every place we find an x, we're gonna replace it with the parentheses and a -5 minus 6. So this will give us -40 minus 6. That gives us -46. Now, I want to remind you that if you have a curve here, right, what we're saying is that at this curve, right, at -5, the slope at -5 of this curve is -46, right? The derivative of this is -6, which is the slope at x equals -5, right? The instantaneous slope of that curve. But what we also know is that at that curve, you can trace a tangent line from there, and we said that tangent line and that curve at x equals -5 will share the same slope. So what I'm saying is that this tangent line, a tangent line is always a straight line, has the same slope as the curve. And the goal for the next problem is to find that equation of the tangent line. Well, an equation of the tangent line is always linear, a linear equation. So we know always that tangent lines always look like this. So we already know that the slope of the tangent line has to be the same as the slope in the curve. So therefore, what we know is that that m must equal -46. So m equals -46 times x plus b. So we're almost done. We have half of the work done. What we need to do is find that b. Now we have too many unknowns because this is an unknown, this is an unknown, this is an unknown. Now this is a variable, and this is a corresponding value for this variable. This is supposed to be a constant. So we can always make this equation true if we know a corresponding x value and a corresponding y value, meaning that these two correspond to each other. And we actually do. We have x here, right? We have an x value, an order point, and that's the point here. That's negative 5, 134, right? So we have the x and the y, right? So that means that we can replace that y with 134 and replace that x with negative 5, and that will leave us with one unknown. Right now there's infinite order pairs, right? But there's only one order pair here in that line. So let's solve for b. So we're gonna have negative 46 times negative 45. Let me get my calculator, and I believe it's going to be 230 positive, right? Because negative times negative is positive. And then to solve for b, we need to subtract 230 on both sides of the equation, and this will give us with negative 96. So what this is saying is that b is equal to negative 96. B is negative 46. So hence the equation of tangent line, the tangent line equation, is going to be y equals negative 46 times x plus our b, which is negative 96. So there you go. You found the tangent line. Now, if this is true, right? If this is a tangent line of this curve, and they both have the same point, then if we decide to graph them, then we should be able to see this tangent line touching or kissing this graph. So actually, I do have the picture of this. It's right here, right? So you see the original function in red, the original curve, right? And then we see the tangent line in blue. And if I put my dot here, if I put my dot there, you see there, that's the place where they are kissing, right? So that's the tangent line. So they both have the same slope, and we can kind of zoom out to see that that's actually in fact true, right? That there's no other point. Anyways, I hope you guys find this helpful. Please let me know if you have any questions. Now, by the way, this is a common type of problem to find the tangent line of a curve, right, at a given point. All right, so you have homework problems like that, so let me know